let's consider differentiating the inverse hyperbolic sine of x. To do this, let's just label the output as y. Since I don't know anything yet about its derivative, but I do know something about the derivative of the hyperbolic sine function, let's you and I take the hyperbolic sine of both sides. I want to find dy dx, so let's you and I dive in, treat y as a function in x and differentiate implicitly with respect to x. And now in isolating dy dx, but it is the case that this is a true statement. Now take a peek at this beast. If I isolate this equation, another name for that term right there is just x. And if I take the square root of both sides, I clearly see my denominator can be expressed in this way in terms of x. You may doubt whether I should take a positive component square instead of negative, but when you look at the graphs, it's pretty clear. So there it is. I likewise have the output, it's not the output, I likewise have the derivative of this function, the same thing, but yet again, with a sign change in the second term in the radicand's position. As far as this one's concerned, how about if I have a change of pace? Instead of implicitly differentiating, let's do something different. And like my last example, let me just differentiate directly defined with a derivative of that function. Differentiate directly defined dy dx. The derivative of the natural log of anything is 1 over that thing. But the chain rule says now I have to multiply by the derivatives with respect to x of whatever is initially taken the natural log of. Now let's differentiate using the quotient rule. Here's downstairs. Here's the derivative upstairs. Here's upstairs. And here's multiplied by the derivative downstairs. All over my denominator squared. These two terms cancel. I'm left with a 2. Now these 2's cancel. One of these 1 minus x's cancel. And I'm merely left with 1 over the product of these two binomials. But that's just a factor form of a difference of 2 squares. So let's make it official. I'll leave the remaining 3 to you. But again, these are the most important ones we will be dealing with. Maybe not this semester, but next semester they'll become fundamentally important to us. Now, I'm going to leave it for you to get some practice in differentiating maybe a combination of these functions with the other functions with which we're familiar in terms of the calculus, like composition, multiplication, ratios, and differentiating as such using our various different differentiation rules.